So now at long last, we're finally ready to start talking about the Completable Futures API, the API of the Completable Futures framework, in some detail. And we're going to start out by giving kind of a bird's eye view of the overall structure of this framework. And then in this part of the lesson, we're going to zoom in and talk about 3 of the groupings: the basic methods, the factory methods, and the completion stage methods. Part 2, of course, we'll talk about the other 2 groupings. Now, why do we even need to think about groupings? Well, the reason we need to think about groupings of these methods is because the entire Completable Futures framework lives in one class with over 60 methods in it. And they keep adding new methods as Java evolves. So there's probably more like 70 methods now. It just keeps growing and growing. So there's a lot of public methods that you have to deal with. And there's a whole slew of private classes and private methods. So it's a pretty big, complicated class. You can think of this class as implementing something called the facade pattern. The facade pattern is a good old gang of 4 pattern, the design patterns catalog, gang of 4. And it basically describes, its intent is to provide a unified interface to a set of interfaces in a subsystem that makes the subsystem easier to use. And what we mean here is, if you were to look at the implementation, there are, again, dozens of classes and all kinds of helper methods and all kinds of complicated asynchronous programming written in Java that looks like C. But you don't want to have to see how the sausage is made. You just want to have to focus on the interface itself, or the class itself, which is the Completable Future class. So it's basically a facade that hides all that complexity from you. So let's talk about how to group the API. So given the large number of methods, it helps to have a bird's eye view. This is a very famous bird's eye view. This is actually an astronaut eyes view, or a camera run by an astronaut eyes view. That's called Earthrise. It was a famous photograph taken of the Earth as they went around the moon, which is kind of cool. No one had had that view of the Earth up till that point, which is kind of neat. So that's about the ultimate bird's eye view. So some of the Completable Future methods are very basic methods. These are the ones that come from the Java Future interface that is inherited or implemented by Completable Future. So those are the basic methods. So here's what they are. They should look very familiar to you by now. Cancel, is canceled, is done, get, and so on. And you can see that those appear in Completable Future, along with a couple of other very basic methods. Join, which is essentially a variant of get, and complete, which allows you to complete a Completable Future with a value. So those are very simple. You would be remiss if you focused your use of Completable Futures only on those basic methods, because it would be like, what was the point of that? You should just use a future. But you should not use a future, because it's got limitations, as we saw. Mercifully, there are a bunch of other more advanced Completable Future methods, which we're going to talk about. So factory methods, completion stage methods, arbitrary arity methods, which is a funny name, and exception methods. So let's talk a bit about these. Let's talk first about the so-called factory methods. So as you might think, as you might guess, a factory method creates something. And in this particular case, they're going to initiate asynchronous computations without requiring the programmer to explicitly create threads. So this is the thread. There are threads, of course, but they're done behind the scenes, typically in a pool of something or other. And you don't have to think about that as a user of Completable Future. You just have to say, here is some computation I want to have run asynchronously. And there's both two-way and one-way factory methods. The ones that are called supply async are used to give two-way calls. These are suppliers, so you can get a result back. And the ones that are run async take runnables, and so they don't have a response coming back directly. If you need to get something done as a consequence of calling a run async runnable, you need to have some side effect, put something in a queue or send a result back somehow or whatever. So those are the two types of factory methods, supply async and run async. We'll talk a lot more about them in more detail later. Factory methods help to make your programs more elastic by leveraging a pool of worker threads. And you can decide what type of threads are in that pool. By default, they use the common fork join pool. There's a couple of things here that take nothing except a supplier or a runnable. That uses the common fork join pool. by default. But there's also methods where you can provide executor implementations that can create the thread pool or give you access to the thread pool of your choice, which could be either predefined thread pools like a fixed size thread pool or a cached thread pool or some custom fork join pool, or you could make your own thread pools if you wanted to. The next set of methods, which are really the big ones, the biggest one by volume, as you can see here in this little pie chart, are the completion stage methods. And what they do is they chain together actions using the fluent interface pattern that process the result or the results of asynchronous operations. So the basic idea is when you start an asynchronous operation, typically by using supply async, that factor method we just talked about, as that computation finishes, then you can chain together a bunch of completion stage methods. And there's a bunch of them. I just put a few of them here. And they can be used to do something with the results that complete from previous stages in the chain. So as an asynchronous operation completes, you can have a dependent action that's called to continue the processing, usually asynchronously, by the way. And what's really fascinating about the completion stage methods is they can be triggered based on different numbers of prior operations. Some completion stage methods, like, say, then apply, trigger when one prior stage completes. So you might start an asynchronous operation with supply async running in the background to reduce a big fraction, for example. And then when that completes, you call then apply, and you convert it to a mixed fraction or whatever. There's different things you can do. So there's some that apply when one thing finishes. There's other operations that apply when multiple things complete. For example, the then combine method will actually take another completable future, and that method, the then combine method, only triggers when two previous completable futures finish. And we'll see there's a whole bunch of cool use cases where you want to join the results of multiple flows, in this case two, to have something happen when two asynchronous things occur. And then you can start another asynchronous thing. It turns out there's also another set of completion stage methods that will finish when either of two things complete. So you can do and or style programming with asynchronous computation results. Completion stage methods help to make programs more responsive by not blocking caller code. And you'll notice I'm referring back here to the principles of reactive programming. So we talked earlier about the factor methods making things more elastic. Completion stage methods make things more responsive because they don't block the caller code. They let the caller code continue running, doing its thing while computations run asynchronously. And then these dependent completion stage methods can be used to get the results and continue the process if desired. So that's the end of part one of our discussion of method groupings in the Java Completable Futures API, namely basic methods, which are kind of boring and don't get used a whole lot, the factor methods, which you really need to use to get things going, and completion stage methods, which handle the processing of results as they finish running asynchronously.